Good evening, madam. We from Group 4. Our group members have AMEESHA, Debora, NADIANSYAH, Nurin, Iman, and me, Bang Jiaqi. Today, we will present about the random variables by variable distribution. Then I will pass to the next presenter to present the introduction.
Okay. For the first, we know our topic is real world application for random variable such as variate distribution. So statistic is a subdomain of mathematics that deals with the collection, organization, description, interpretation, analysis, synthesis, and presentation of data. So we know statistical analysis can be broadly classified into 7 categories likely, namely descriptive statistic, inferential statistic, predictive analysis, predictive analysis, causal analysis, mechanistic analysis, and exploratory data analysis. For the next, we use random variable iaitu variate distribution. So we know the variate distribution are statistical method used to show the probability of two random variables occurring. So one of the most common method used to display this information is with a table, for example. So to have a variate normal distribution or a joint normal distribution, so both random variable needs to be normally distribution as well. And the variable need to be independent, and the result of one variable cannot affect the result of the another variable. So the application we use is the medical field. So I pass to the next presenter.
Thank you from the previous presenter. Now I will present about the real-world application in medical fields. In medical fields, we will analyze of the relationship between two health-related variables or factors. This type of analysis is often critical in epidemiological and clinical research. In epidemiological, we will estimate the joint distributions of two variables by using bivariate distributions, while in clinical research, we can be employed to study the associations between two clinical variables by using bivariate distribution. Other than that, in epidemiology, we can assess the risk factors associated with a particular disease or conditions. These informations can help identify populations at higher risk, understand the impact of different factors on disease progressions, and guide public health intervention. Well, in clinical research, we can investigate potential relationships such as whether elevated blood pressure is associated with higher cholesterol level. This knowledge can contribute to the development of diagnostic criteria, treatment guidelines, and personalized patient care. In summary, bivariate distribution and random variables are important in medical research by allowing for the analysis of the relationship between two health-related variables. Purpose of this analysis is understanding risk factor, developing treatment strategy, and improving patient outcomes. Then I will present the demonstrations about the patient's blood pressures and cholesterol level. First step, we will collect data from a sample of patients, measuring their blood pressures and corresponding cholesterol level. For each patient, we have a pair of observations, which are blood pressure and cholesterol level. We have to take note about blood pressure is independent variables, while the cholesterol level is dependent variables. The second step is statistical analysis. Perform statistical analysis on the collected data to understand the relationship between blood pressure and cholesterol level. We can do this by calculating the correlations coefficient, which measure the strength and directions of the linear relationship between the two variables. The correlations coefficient range from -1 to 1. Range in -1 indicated a strong negative correlations. 0 indicates no correlations, and 1 indicates a strong positive correlations. The third step is bivariate distribution modeling. Based on the data and statistical analysis, we can construct a bivariate distributions to model the joint distributions of blood pressure and cholesterol levels. The bivariate distributions, such as the bivariate normal distribution, describe the joint behavior of the two variables and provide information about their means, values, and correlations. The fourth step is inference and interpretations. Using the bivariate distribution model, we can make inference and draw conclusions about the relationship between blood pressure and cholesterol level in the patient populations. For example, we can estimate the probability of observing specific cholesterol level given a range of blood pressure values or assess the impact of changes in blood pressures on cholesterol level. The last step is about the clinical applications. The insights gained from the analysis of the bivariate distribution can have several clinical applications. Healthcare professionals can use the information to assess the risk of cardiovascular disease based on a patient's blood pressure and cholesterol levels. They can develop guidelines for managing blood pressures and cholesterol in individuals with different risk profile or custom treatment plans based on the patient's specific blood pressures and cholesterol relationship. That's all from me. Then I will pass to the next presenter.
Okay, so now we will move on with the example. For example 1, a diagnostic test for a particular disease is conducted on a group of patients. Let X represent the test result for the first patient and Y represent the test result for the second patient. The test can yield either a positive or negative result. Answer the following questions. A. Determine the possible outcomes that represents X and Y. B. Determine the possible pairs in the sample space, and C. Determine the probability associated with all possible pairs of values. Moving on. Okay, so to answer question A, in this case, the possible outcomes for X and Y are the test results. So it is either positive or negative results. For B, determine the possible pairs in the sample space. Since it is either positive or negative result, therefore the sample space will be positive, negative, positive, positive, negative, positive, and negative, negative. Next is question C. So the probability associated with each possible pair of values can be assumed equal since there is no additional info given. Therefore, each outcome is equal. There is an equal probability of occurring. So we denote this probability as P. So since the sum of all probabilities must be 1, therefore we have 4p, which is the sum of all the probability, equals to 1. When we divide both sides with 4, we will have p is equals to 1 over 4. Hence, the probability associated with each possible pair of values is equals to 1 over 4. Next one is example 2. In a clinical trial, patients are randomly assigned to receive either a new medication or a placebo. The patient's response to the treatment is measured using a rating scale where higher scores indicate better outcomes. Let X represent the score of a patient receiving the medication and Y represent the score of a patient receiving the placebo. A. Find the domain for X and Y. B. Obtain the joint probability distribution of X and Y. C. If A is defined as the event X less than equals to 2 and Y equals to 2, what is the probability of A? D, if B is defined as the event x equals to 3, what is the probability of B? Next slide. Okay, question A. By assuming the rating scale ranges from 0 to 10, therefore the domain for x and y are the same, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 8, 9, and 10. B. Since the problem doesn't provide a specific probabilities, so let's assume that the probabilities are uniformly distributed. Since x and y are independent variables, the joint probabilities distribution can be calculated by multiplying the individual probabilities, which is the probability of x and y. So by assuming px equals to x, which is 1 over 11 for each x in the domain of y, hence the joint probability distribution is equals to uh, 1 over 121 for each combination of x and y. Question C. If the event A is equals to x less than equals to 2 and y equals to 2, then the probability of A is the sum of all the probabilities that satisfies uh, the joint probability distribution that satisfies this condition. So since the joint probability distribution is uniform, therefore we have 1 over 121 plus 1 over 121 plus 1 over 121 is equals to 3 over 121. Question D is also similar with the previous question, but it's just that the event B is x equals to 3. Therefore, we will sum up all the joint probability distribution that equals to this event. So the probability of B is equals to 1 over 11. That's all from me. I will pass to the next presenter.
Okay, this is a Q&A question. So my first question is I want to ask to Cha. Can I ask to Cha? Okay.
Yes.
What is the purpose of vibrate distribution and give me the example?
So the purpose of bivariate distribution is a distribution showing each possible combinations of value for two random variables according to the probability of occurrence. For example, a bivariate distribution may show the probability of obtaining specific pairs of height and weights among college students. So for the next question, um, I will ask NADIANSYAH, what is the useful way to display a bivariate data?
Uh, I think the most common method of visualizing the relationship between two continuous variables is by using scatter plot. In a scatter plot, each data point represents one observation and is plotted on coordinate corresponding to the value of both variables. This allows you to see pattern, relationship, or correlation between the two variables. So for the next question, uh, why is bivariate data analysis important? Can you answer the question, Amisha?
It was important statistical method because it lets researcher look at the relationship between two variables and determine the relationship. This can be helpful in many different kinds of research, such as social science, medicines, marketing, and more.
Thank you, madam. That's all for us.